Lunch and Learn is an MFG radio network production brought to you by GIE Media's Manufacturing Group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition. Hello and welcome to the latest Manufacturing Lunch and Learn from GIE Media's Manufacturing Group. I am Jake Kaufman, the senior editor for the group. Today we're joined by SW North America, part of Swabish Werskinaskinen, also known as SW, a global leader in smart manufacturing systems. Headquartered in New Hudson, Michigan, SW North America is recognized for its high-performance multi-spindle CNC machines. These machines are used to produce parts for cars, electric vehicles, medical devices, agricultural equipment, and even aerospace components. SW employs more than 1,700 people worldwide, with teams in Germany, France, Poland, Italy, Hungary, China, Mexico, and the United States, all working together to push the limits of advanced manufacturing. This session will highlight one of the most important industries where precision and innovation can truly make a difference: medical technology. SW offers specialized machining and automation solutions that help medical manufacturers scale production, stay consistent, and deliver top-level quality. Their systems are designed to handle everything from implants to surgical tools and diagnostic equipment, with a focus on accuracy, repeatability, and flexibility, even in small batches. Medical manufacturing comes with its own set of challenges like strict process validation, just-in-time delivery needs, and fast-moving technology. SW works closely with manufacturers to meet these demands and turn them into real advantages. Featured in today's session is Matthias Dreher, medical technology expert at SW's global headquarters in Germany. He will share customer success stories, explore key industry trends, and answer questions on how SW's capabilities can support smarter, more agile medical manufacturing. Without any further ado, let the session begin.
All right. Hello. Good afternoon. Thank you, Jake, for the introduction of SW and myself. I'm very glad being here today and present you guys the solutions from our side for the medical industry. So I will share my screen to show you a presentation about SW. By the way, Jake, I correct you a little bit. SW means Schwäbische Werkzeugmaschinen. It was pronounced different by yourself, but it's a pretty hard wording for somebody not coming from Germany. So let me share my screen so I can show you the presentation. Hang on a little. All right, so here we are. So today we are talking about the smart manufacturing solutions for the medical industry. I would do it a little bit divided. First of all, I would like to show you a little bit of introduction of SW, the company itself, where we are, what we do, where we are coming from, some figures, some numbers. And later on, we go a little bit deeper into the medical topic, show you some concepts we have realized by customers we are working on at the moment as well. After the presentation, I will go into 2 or 3 videos we made on success stories together with the customer. And after that, I'm very, very open for your questions you might have. So let's get in. So I will talk a little bit about our employees, technology people, the SW global sites, the numbers, and for sure the products which are the one we are taking care of in the medical industry, the 2 or 3 machine types we are using. Before that, our claim is always best per part. So that's our focus. That's what we are looking for. You see on the screen some parts, and only the very, very small ones on the top left side are those ones reliable to the medical industry. Yeah, so there we are talking about very huge components, as you can see, but also very, very small components. And we're always looking on the best solution, the best fit, according to the requirements you have on the workpieces, but also to customize the machines on that side. These are some colleagues of mine taking care that everything is running smoothly in the company. And Therefore, we are always trying to make the difference somehow in comparison with our competitors. So we are looking forward to have always the customer-orientated view on the things. We want to be on site. We want to be there for you in terms of the location, in terms of the idea, in terms of the concept. And we always look for the high-tech solution. High-tech are two words. That's good here in the marks. Two words. So we not only offer high quality, we also offer the cutting edge technology. How they write it here. That means we know that with the productivity of our machining solutions, the demand for the quality is very high. Multi-spindle machining centers, but also the technology behind that, all technology which is referring to your needs, to your requirements, also needs to be understood. And that's why we see these two topics as one of our main overall view on things to make the difference. Then we are also looking forward to have reliable solutions for sure, not only taking promises, but also keep them. Yeah, we love the challenges for sure. We are, especially in the non-automotive industry, looking for them at the moment. We are on a diversification way currently, which means that we are focusing out of the automotive industry into the non-automotive industry, and to check there the possibilities which are given in the market. The market has changed in all kind of industries, mainly in the medical industry and in the aerospace industry, but we can talk about that later on. And then also we do looking forward to have customized solutions for our customer. Customized means you give us your components, or the customer gives us the components, and we look for the complete solution around it, not only to having the machining solution, but also the complete technology package, which means fixtures and cutting tools, but also process developments. And looking into the bigger view, we also are looking forward to have the system technology afterwards or beforehand, like handling the parts with a multi-flexible machining, with a multi-flexible automation solution to pack the parts afterwards, to make some checkings, however assembly works, and so on and so on, and everything from one hand, everything from one supplier, so that there is nobody else needed on that to realize a complete project. In the short introduction movie, you have seen our locations. Yes, they were absolutely right. As you can see, the headquarters is in the very south of Germany, very close to the Swiss border. Some of you might know Europe and the Lake of Constance. It's very centralized in Europe, and therefore we have for sure many subsidiaries in Europe. Very often in Eastern Europe, as we see that the market is growing there. And then we have our subsidiary for sure in the US, in New Hudson, to cover the US market. Yes, and with our team there, it's very important to be also there for the support of the non-automotive industry as well. And I can mention here that on the 8th of August, we do have our open house there. So if you're very invited, if you want to stop by, just do it. Display of some machines. We have a big aerospace machine being there, display some parts of the wing ribs, and very much more of very interesting communications and discussions there. So you see, we are very, very globalized. You want to say we have two main subsidiaries. One of them is SW North America in New Hudson, and the other one is the one in Suzhou in China. There we do the technologization of the machines and bringing them, so to say, to the key turnkey solution for the customers. So we are where, let's say, our customers are. We do work with some smaller offices in Northern Europe and in Asia as well, and in Brazil. But we have founded as new subsidiary this year in India. So we see the market is growing there. So we do go there, not only for sales, but also for services, to be on site, to have the spare parts there, to be locally and globally on site. The amount of people's working for SW you see here. So in total, we are around 1,800 peoples at the moment. For sure, the main amount is working at SW at headquarters with roughly 950, but also roughly 100 people are working at the SW North America plant, and you see how it's covered. So some of them in the production, so it's one third sales, production, and then for sure spare parts center or service center to be ready for you, for your needs. However, whenever you need somebody, we are there. Some figures for that. So 432 million euros in sales in 2024, and now already more than 6,000 machines delivered into the market worldwide. Seen, it's quite a high number for us, being started in 1995. We have 1,700, 1,800 people's employees working for SW at the moment. 12 countries we are in, with subsidiaries, smaller ones, bigger ones, like I've said. And which will also be a slide later on, is the data service or industrial data services industry 4.0. It was mentioned before. But we are working on that since many years and have good successes there. And we have roughly a number of 220 service employees worldwide. And I think this number is very important, very good, as we are working only with own service technicians. So we do not have some partners here and there, because we do not want to be in between the customers. We want to have a request for help, and we want to send our technicians there, and we do not want them to be somewhere else or with some other supplier. As you know, we are building machines, multi-spindle machines, but also single spindle machines, and you see here the let's say the number of machines installed in the market, and with the colors you see the machine type, let's say. So red is single spindle machine, gray is double spindle, black 3 spindle, green 4 spindle machine. And you see in the US we have for sure always a lot of double spindle machining centers. Those are the high running machines with us, but also quite a lot of 4 spindle machines. And in Europe it's a little bit different, more double spindle than in the US, and China is nearly the same as in Europe. And in Brazil mainly we are installing quite a lot of 4 spindle machines. There is a huge production of ABS cylinder blocks being realized there, and they use 4 spindle machines. Single spindle machines are used for huge parts, also in the non-automotive industry, for industrial gear components, let's say huge housings, which you do not handle within a double spindle machine at the moment. As I said, short history, 1995, founded out of Heckler & Koch. Some of you might know HK. Heckler & Koch is a German gun and weapon manufacturer. We have a combined past together, and out of that Heckler & Koch machine tool company, there was 1995 a management buyout, and the Schwäbische Werkzeugmaschinen SW has been established. And then you see the growth during the past years has been going on. A lot of extensions, taking overs of our SW Automation company, the company or the subsidiary which is taking care only of automation solutions, not only handling parts into the machines, but also doing the assembly of components like battery boxes and so on. You see 2017-18, there was the new construction of our new Hudson plant. So we are very proud of that. I have been there for the opening ceremony. It was really nice being there and seeing this new facility back then, and still it's going really strong in the US. And here on the bottom, you see our current 3 general managers. It's Daniel Drieser for sales, Stefan Weber in the Center for Technology, and Mr. Kai Pironczek for finance and human resources. So let's go a little bit into that, not a little bit, but let's go into the medical technology topic. You see there already one machine we are mainly using on. It's a WO2 machine with an integrated automation cell in front of it, but we will have the chance to look at it a little bit more deeper. When it comes to smart manufacturing solutions, we have some bullet words or points, what we call it a smart manufacturing solution, because it's always relying to productivity, the flexibility, modularity, and the connectivity. And what we see and what we have learned in the past is that the flexibility and the productivity are the one or the two topics which are growing very, very fast and which are even more important now in the medical industry. High productivity, even though with small lot sizes, with different family types, with the high flexibility, and these combined within an automation system, within a machine, gives then us the modularity and then the connectivity with the systems afterwards. Those are the branches we are serving in. I have mentioned that. We look at the medical industry for now. If we look at the parts, if we look at the components, if we see and if we want to machine those, we need to have a reliable machine. So our machine design is from the smallest machine to the biggest machine, always the same concept. We have a monoblock in the center, which gives us the base for the machine. You see it's kind of a closed frame. It's a welded steel construction from the bottom up to the top, and we do it within a steel construction and a closed frame because of the temperature growth. The same material and a closed frame gives us a very smooth temperature growth, a very controllable temperature growth in the machine, which we can control within the probing systems, and therefore a stable process afterwards. We do have then our box-in-box unit. I will show a movie later on. Box-in-box unit where the spindles are located in and all the surroundings of the machine. We do have a Q-axis. That means we can load from the front while we do machine on the back side of the table, and we do have a linear drive and ball screws available. So we need to see what material do we want to machine. Is it titanium? We can use linear motors because titanium is a non-ferrous material. Or do we machine stainless steel? Also can be non-magnetic, but it can change magnetically if you cut it, and therefore we also have the ball screw solution so that we can serve all different kind of materials. Those are the machines we are looking on, as said, as screw machines, ball screw machines, or linear motor machines. Starting with the smallest machines, double spindle machine, 2 spindles with a spindle distance of 200 millimeters. And with WO2, with linear motors, with 250 millimeters, with the integrated automation solution. Then the next size with 300 millimeter spindle distance and 2 spindles. And the last one, which we consider to be used in the medical industry, is the 342. It's a 4 spindle solution. We are working on a concept at the moment for bone plate machining with 4 spindles, actually, to have even a higher productivity, which seems to be very, very good. So I've seen the first results this morning, very interesting. And we also have a customer in the US which has already taken advantage out of that and selected one of these nice machines for their production of bone plates. So these are the machines we are looking for. Just to tell you, we are looking at 300 millimeter spindle distance. And now I tell you the biggest machine so that you can see or think about the comparison. The biggest machine has a 3 meter X travel range at the moment. So 3,000 millimeters. And We are working on a new solution now for the aerospace industry with having 5,000 millimeters travel range compared to the ones we are using for the medical industry of 300 to then 5,000 millimeters. So what are we looking in terms of work pieces within these, let's say, branches within these industries? For sure, there are two types. Yeah. So one special type is the implants, yes, and the other ones are the instruments. So the implants, as it said, they are being implanted into the body. They stay in the body. Some of them will be removed, some of the bone plates, yeah, but mainly they stay and remain in the body for a certain time or forever. And then we have the instruments on the other side, which are being needed to actually do the operation on the human body, to needle holders, the scissors, tweezers, staplers, fixators, and so on. And those are the two main components we are looking at. So there are disposables and stuff, and some endoscopes with their light base. I mean, these are very important and very high-tech instruments or units, but we are focusing on the ones which can be machined. So on the endoscopies, for instance, we are looking for the handles of the endoscopies, which being machined out of stainless steel, out of titanium, however. So these are the ones we focus on. We do have realized projects for knee implants. So I cannot come over to my screen here. We do have projects for bone plates, as I have mentioned, knee implants, hips, shoulders, not yet, but it's kind of the same concept as for the hip implant and the elbows. You see some samples here, down there. And we have a nice concept, new developed for needle holders, for tweezers. I will show you a little bit of. I cannot show you too much because there's still the projects going on. And we did have realized the stapler and parts and handles for endoscopies. So this is the concept we are using on modularity, integrated automation. Here you see how the robot is attached to the machine and handling out of the pallet stacker in the backside. It's handling the parts from the loading area into the fixture. And here from the fixture, we are then rotating the table into the working area. I will show you that later on. So either way, you handle a pallet tray yourself, or either way, a AGV, automated guided vehicle, is taking the trays in and out of the storage system in the back, and so you only have a place where you are taking care of the raw and finished materials, or you bring the tray yourself into the cell. This is how it looks like from the front. Here in the back, you have the pallet stacker, let's say, or the pallet system, which goes up and down. The robot pulls out the pallet out of the tray and then feeds the machine. I have an example for a needle holder here. We do have space for roughly 144 needle holders. And for one set of needle holders, we have a cycle time of 9 minutes. Yeah. So if we calculate that with the capacity of the storage system in the back, we are talking about no, I'm missing the word, autonomy time of 21.6 hours, right? And within that time, for sure, at some certain point, you will exchange the finished pallet trays, and this is quite some very, very good autonomy, I would say, and all combined together within the machine. So everything is very neatly, very smooth attached to the machine. So you might not see a big change from the automation system to the machine itself. And it's kind of a plug and play solution. So we do install the automation right within our facility in Germany, and we ship the machine together with the automation attached already, because it's fixed to the base of the machine itself. Very interesting concept here. Using that system, we are coming to the concepts we are working on. So we say laying instead of flying. So it's in German. It's German translated, but I thought I would try to explain it to you. So this is the concept how instruments could be used, could be machined, if you do the machining out of the full material. Normally, I need to mention the raw material on the instruments, kind of like needle holders, are forged material, right? So they are forged into the form and then they are cutted out and then you get a forged blank. And the problem is these forged blanks, they have a very, very high and very, very long delivery time, and they are going more and more and more expensive. And the demand for those blanks is very, very high. And therefore, a customer of us has looked for a different solution, for a new solution to get away from these forged blanks, to get into a better solution for that. And therefore, we came up with a machining out of the full material. So we take these needle holders and machine it out of the full blank, as you see here, out of the full warm rolled stainless steel blank. And we tried flying like this, but we said that's not very, very economic scene. You have a quite high cutting time, you have vibrations on the part. So our concept now is doing it laying down, clamped very, very proper, and then we machine the part out of the full material until we have on the bottom only some pins left, and the robot goes there and grips the part and rotates the part out of the pins and places it in the operation 20. And with this concept, which we are running a patent at the moment, you can machine a small family of different sizes without setting up the machine for a different clamping, right? So you do on top operation 10 machining, and on the side you have different possibilities to clamp different lengths of that family without doing a new setup, and then you can finish different requirements, different lot sizes, different amounts within one small order, 20 parts or 40 parts per order, and you have the full flexibility given with the automation system. And together with that, on that side, we only do the finishing of the second side, and the main request is taking the parts out of the machine, bringing them into a vibration grinder. Please don't name me on that, but I guess it's the right wording, on a vibration grinder, and then after that directly into the assembly, which means between machining and assembling, we do not have any manual work to do on those components, and we do have a very high productivity, a very high flexibility with that clamping system within that machining concept, and helping the customers to be prepared for the future challenges of cheap competitors coming from far and near east, let's say. Then also a concept which we have realized with the customer is the multi-spindle machining of the bone plates. I have mentioned that. So double spindle, it works very fine. It works very good. We have realized the concept of wrist bone plates in that case, and was a good concept here. We are working on a 4-spindle concept now. Tests are going on, and like I said, we already have realized that it's a very, very interesting concept, very productive. The raw material is always kind of the same. It's a little bit longer, it's a little bit shorter. With a different clamping concept, you can use the same clamping without exchanging the jaws, exchanging the grippers, and still being able with that flexible automation system to use this and install it, use the same material and handle the same fixture components and machine it afterwards. This is a concept we also run a patent on. So this is, as I said, not very good pictures, but it's running at the moment. I have seen it this morning in the production facility. This is kind of a bar feeder inside the 5th axis, which means that we can push the material out. In that case, it's aluminum extrusion profile for bipolar tweezers, to machine bipolar tweezers out of aluminum extrusion. And the extrusions is designed to cover different styles, different types, with a bended peak or with a straight peak, however. And then also with the automation that handles only the cutted extrusion parts, and then the bar feeder inside is pushing those components upwards, and the robot is breaking them off and bringing them on table 2 into the operation 20 to finish the backside of the tweezers. I can mention there, this is also possible for the production of grippers out of a full steel material. So we are working on a concept for a customer on that. That means we do have a squared stainless steel block handled by the robot, putting it into the center of this 5th axis, and the bar feeder will feed it outwards. And we do have a double spindle bar feeding system on a 5-axis machining center, double spindled. And we always do then kind of the concept here. Hang on, here, finish the first side completely, grip off the parts, using the second side for finishing, and then just making roughly flat with rough milling flat, and then starting again by having the 5th axis bar feeder pushing the parts upwards again. Also can be used for the production of spinal cage implants, cages, typically just being set, and also with a running time of roughly 45 to 55 minutes, depending on the part out of the titanium, you can then machine 2 parts at the same time, so your productivity will go up just right away. Those are the solutions. Let's say flexibility meets dynamic productivity. Yes, we are looking for the reliability. This comes due to our linear and torque motors. Yes, they generate the movement which is necessarily needed to have this high dynamic within these different types of drives. We do have the dynamic. We do have this thermostable monoblock. That's what we call it, with this welded steel construction. The productivity and profitability is seen in the combination with the weight optimized design, and to ensure that we do not have too many non-productive times. This comes with the Q axis, where we rotate the parts in and out for loading, and the loading time within the size of these machines is 2.8 seconds. So you do have a downtime or waiting time for the productivity of 2.8 seconds. Wide range configuration options. Yes, we can have our standard basic machine with different options for you, which are necessary. Different tool magazine sizes, different possibilities in hydraulic for the clamping jaws, for the clamping chucks, different possibilities in chip removal systems, and so on and so on. So we can use different configuration options as well. Short bar loader, we just have talked about that. So this is absolutely a new technology in combination with the automation. Perfect system for the full flexibility and productivity, and transparency and process reliability is position tolerance of smaller, same as 6 microns. I guess that speaks for itself, right? And we can produce all different kind of materials, as mentioned, due to the different drives we have. 5-axis full machining possible within stainless steel, titanium, aluminum, standard steel, let's say, as well, but also carbon components can be machined on our machining centers as well. We do have services, for sure. Everybody needs to have services. We have the startup, so we start up the machines themselves, installation, commissioning. We do also offer production support to help your guys, to help the workers to get the machine running into the production. We do have our live help, which means that they are helping you, help center with the technicians on site and so on. We do have an academy to train your guys in programming, maintenance, and so on, all what is necessarily needed to take care of the machine during the whole life cycle. We do have the live data, the digitization, and consulting for all the data we collect and which we can show and present to you. We do have live parts, spare parts, simply as it is, on site, globally around the world, and the upgrade. However, when a project runs out, you need to upgrade the machines. It's always completely doable in terms of technology, which means fixtures, processes, cutting tools, but also in options, 5-axis can be installed or upgraded later on. So all possibilities given within one life of the machine. In terms of connectivity, we do have some products which we called Live Data Core. That means that's the digitize the manufacturing system with our IoT gateway. That means we are able to provide you the data towards your systems, towards our system, towards a cloud-based solution. Everything is possible on that. We do have the SWMP API, which is to connect the machine or automation to your IT systems then, which is necessarily needed with the core. Then afterwards, we have the cloud platform. The cloud platform provides the status of the machine, how many parts have been produced in the night shift, how productive was the machine during the last 2 weeks, what were the alarm codes showing up, has something been changed on the program, and so on and so on. So everything can be displayed within that cloud platform for you, so you have the full monitoring of the machine and their productivity. And then we have also the SCADA platform, which is for the traceability use, workpiece traceability. It's not very common to have the workpiece traceability in the medical industry. For some components, yes, for others not, but very, very common in the automotive industry and aerospace industry, so that you can exactly tell when was this part produced, on which machine, with which spindle, and so on. And also the manufacturing KPIs can be displayed with that. We do also consultancy, plant simulation, the effectiveness of how the flow of the material should be or could be optimized within your plant, digitization, what is necessarily needed, what can be done. So we have some experts on that side as well, and also in regards to the ecosystem, how can we develop those solutions together with you. We do have a data analytics team. They generate tons and tons and terabytes of data out of the machines to analyze and to go into the direction of preventive and predictive maintenance. So this is something going on at the moment as well. So we are looking forward on that. Some references. We have also made success stories with, and I'm now at the end of the presentation. I wanted to show you a movie, hang on, about the principle we have. I think it's very interesting for you to see how our machines are built up. As I said, it's just a short movie. Stay by, you see explosion of the machine. That's the monoblock, as mentioned, torsion-free, force and stable. It's a crane hook machine. It's very easily to place it. After unloading on the floor, that's the swivel carrier, that's the loading side. And then we rotate into the working area while we unload on the other side. We work on the other table side, and then we rotate again the table in and out. The 3-axis unit, which is the Z-axis with the spindles, the X-axis to left and right, and up and down is the Y-axis for the full movement. The Z slide with its different spindle types, double spindle, double independent spindles for Z-axis correction, and we do have different tool tables. It's HSK. It's HSK 40, HSK 50. And drive technology with the ball screw in that case, but also with the linear drives and the tool magazine going up whenever it's necessarily needed for more space. We do not have a bigger floor space then, but we do have more space in tool Tool magazine, sorry. So that's on that. All right, so then I would like to show you also, I need to stop that somehow. I'd like to show you here a movie of needle holder production. It's fast and forward, so yeah, please don't nail me on that, but you see how we do machine the parts, right? So double spindle machining of views, we do have some special tools for the forms, yeah, and then we do get one set, which means left and right part, out of the material, and then finish the part nearly completely. I think it's very interesting to see how those are being machined, because it's very, very rigid and very reliable solution on the machining of those components as well. I don't want to lose too much time. I have seen I'm talking already too long. So let me jump into the next movie I would like to show you. That's bipolar tweezers in that case, at the customer of us. And you see here also we have aluminum extrusion. We go in that case from the front because it's not a 5-axis machining needed for those bipolar tweezers. Therefore, we can have a long extrusion, so we do the machining only with 3-axis movement. You see here, and after the machining or the form has been done, we do cut off the parts, and we do break off the parts here within the spindle, and we place the parts on the bottom, and then the parts are being transported outside of the working area onto a conveyor belt, and then the parts are being brought out. So for the next, let's say, production step in that case, which with the new concept I have shown you with the bar feeding system is not necessarily needed anymore. So let me show you the movie here. It's about bone plate machining, WO2 machine. In that case, the smallest machine because the bone plates are quite small. Well, for the movie we use different material. Normally we know it's titanium grade 5. Yeah, in that case we used a different material that we do not need to cool. Otherwise we would not see anything during the movie. Let me jump a little bit forward. You see we do the outside form first, then we do the pre-rough milling, and going more into detail, then the form of the part is being finished. Yeah, multi-pass milling on that side to get a very, very smooth surface as it's necessarily needed. That this remains in the body. You would feel it actually when there would be not so smooth surfaces afterwards. Jumping forward, as you can see, all features are being machined, and in the end there is a, let's say, kind of a breaking off solution there.
Well, Matthias, thank you so much for your time and your expertise today. Obviously, that was a fantastic presentation. We do have a few questions coming in. So we did have someone who wanted to let you know that they are under pressure from their boss to cut costs, but they also are dealing with a lot of regulations. So they need to have machines that are running efficiently. How can SW help with that?
Well, as I have shown in the movie, the cost pressure is always coming up more and more. So this is a quite interesting question. Yeah, you need to have a reliable machine. You need to have a machine which runs at best 24/7, right?
Mm-hmm.
And
Right.
this is only possible if you do the combination of a reliable machine and a flexible automation solution. If you have an automation solution, it's not, it's good already, but it's not the best solution as possible because of the different part families, of the different sizes, of the small lots within the medical industry. So this is something which is being covered by our machines, I would say. Yeah.
Okay. And then someone also wants to know, with so many changes coming in materials and all the design tweaks that happen in the medical industry, along with, like you were talking about, with the shorter or smaller production volumes, how does that kind of go into the machining aspect at SW as far as how you guys design the machine, knowing that there are new materials, there are design tweaks, and there are smaller production volumes now?
Yeah, this is a tricky question, because if there are design changes in between, for sure, this will affect the way of how to, let's say, design the fixture components, right? So if there is a change in between, you need to have a fixture base which is that flexible to be able to adapt to new challenges or to new changes of the parts. This can be realized if you do a quick changeable system of the clamping jaws itself, which means that you do make them indexable and therefore adjustable to the changes coming up. This is also important for the small families you might have, for the small lot sizes of different parts and different materials. So these can be used as well, that you have in this pallet stacking system, in this pallet automation system, that you do have different raw materials there from totally different parts, right? You do only use a centralized chuck, but with a indexable jaws, and then you take the parts, or the robot takes out the jaws, changes the jaws to the next fitting order, to the next fitting raw material, and then takes the raw material and places it inside the machine. So again, full flexibility needs to be given by the automation system. That's the key for the handling of the machine.
Okay. Also, Mike says that they're dealing with some labor shortages, so they are looking at to whether invest in automation or multi-access machining. Do you have any kind of advice as to if one is better than the other, or should he probably go for both?
Yeah,
Right?
well, labor shortages, yeah, that's always the point. I mean, that's mainly the point. In the meantime, you don't find the skilled peoples maybe you need to handle the machines, to handle the problems popping up at the machines. You have the productivity requirements, and no people's working with it. And first, I would say focus on the automation systems. Yes, and if you have that, you will see if you get a productivity or not. So multi-spindle machines without having the right automation solution doesn't help you very much. Yeah, so you need to have kind of both. If you are in a productivity problem and a labor shortage, it's a bad situation anyway, I
Right.
would say. But
Yeah. Awesome. And it looks like Dave wants to know if you have any favorite examples of cutting down on lead time, reducing the need for skilled labor, how your technology has been able to, really help out one of your customers.
Oh yeah, I have very nice story on that. Unfortunately, I just can tell and not show.
Yeah.
We have made a project test cut for a customer of bone plate benders. This is some tools to bend these bone plates before the operator is placing them on the bone to adjust to the bone. And we had a test cut, and that was starting on that medical industry. It's already years ago, but the customer came in and we showed him our results, and he was really stunned about the quality we gave him. And then he was like, okay, tell me the cycle time you have. And then we said, okay, we are at 50 minutes for one part. And then he said, wow, your competitor already very long in that time is at 55 minutes.
Oh.
And we said, oh, okay, so we are faster, and we do have a quite good quality result. And then he said, yes, you have. And then I said, and we do it double spindle. That means within that 50 minutes, we do get two parts, right?
Yeah.
And this was for him. He was just staying there and looking at us, and that was really a very, very nice story behind it. So it's the benefit you have. Yeah, actually, it's the benefit you can get out of these multi-spindle machining centers. This is really, really, really interesting and very nice to see all the time. Yeah.
Awesome. So looking like that's probably about all of the questions that we had coming in, Matthias. So obviously wanted to say thank you for joining us from the SW headquarters in Germany. I will work on the pronunciation of the name.
Don't worry.
So next time we speak, I will be fluent in the pronunciation. So once again, sir, thank you so much for your time today. I appreciate your expertise, and I'm glad that you were able to join us from across the sea.
Sure. Thank you very much for having me, and wish you all a good day. A rest day. I'm already in the evening, so have a good time. Thank you very much.
All right. Thank you. You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.